Okay, 8th graders. Last one for Module 9, 9-3, page 501. This is on similarity and transformations. So we just talked about congruence. Congruence means it matches equally. They're the same size, shape, everything, whether they're flipped, reflected, or not. You would write congruence as that tilde and the equal sign. Now we're going to get into similarity. That looks like a pretzel, not a circle. Sorry. Similarity, and they don't show you it on section 3. They only show you it on section 4, which is ridiculous. But similarity is shown with just the tilde. So we're on 501, but if you flip to 513, there's the symbol, the little tilde. That means similar. You can see below are congruent, and below that are corresponding with equal signs. I just want you to get the gist of this right now. What similarity means is it's a similar angles, similar, it would match if it was either made to be a bit bigger or smaller. So basically, it's not congruent, but it could be. The dimensions are the same. Have you ever tried to enlarge a photo or something on your phone or online? And if you just lengthen it, if you take like the box and you just pull it to the side, it becomes this really long rectangle. But if you take a corner and you make it bigger or smaller, it keeps those dimensions. That is similarity, which is the best for when you're trying to get a picture to not be too pixelated. So what I want you to just understand is that some figures are similar, even though they aren't congruent. So you can figure this out by dilation and scale factor, so you can make things bigger or smaller. This is good for graphic design, engineering, architecture, all that stuff again. Basically, if you have a figure and you keep making it bigger or smaller, but keep the same dimensions, it's going to be similar. It's kind of like a fraction that is equivalent to another fraction. If you have half, it's equivalent to 4/8, and that's equivalent to, 50/100. All that. Those are all the same. Like the half would be real tiny, and 4/8 would be bigger, and 50/100 would be huge, right? But the dimensions are going to be the same when you break them down. That's kind of what this is saying. You can show two figures are similar if the second can be obtained from the first by a sequence of dilations and congruence transformations. So if you start with which figure here, which one is the pre-image, the first one? It's going to be the blue, the one without any of those apostrophes that we talked about. When you have one apostrophe, that's the image, that's the second one. And then when there's two, this is new for you, there's two apostrophes, that means this is changed a third time. So it starts off here. Is this similar to that? Well, let's see. If we were to enlarge it and then translate it to the right and over, we could get this figure, which then is congruent to that one. So meaning this one is similar in size to there. All right, I'm just gonna, whoops, page is sticking. There we go. Over here, triangle ABC, is it similar to triangle DEF? Okay, so now is where your Pythagorean theorem and all that stuff's going to come into place. They gave you the hypotenuse, 10 and 5. So now you need to check here. 1, 2, 3, 4. There's 4 between B and C. How many between E and F? 1, 2, 3, 4, 5, 6, 7, 8. So here's those I just talked about. One of them, B and C, is 4. E and F is 8. That can be reduced down to 2/1. The numbers they gave us, 10 and 5, 10/5, that can be reduced down to 2/1. And you could do it backward too. You could have the 1/2. As long as they are equivalent fractions, it's not going to matter. Over here, D and F here, and A and B, 1, 2, 3, and D and F is 6. That reduces down there too. That means they're similar. They all reduce down, or enlarge, you could say, which one you were starting with, by a scale factor of 2, because 2/1 is 2. So that's what they want to know. All right, can you dilate this, enlarge it? So dilate and enlarge are kind of the same, or do you scale it down? How would you do this? If you dilate it by 2 and flip it, reflect it over the y-axis and translate it down, let's see, be 1, 2, 3, 4, 5, a whole bunch. Translate it down a whole bunch. Oh, there it is. It tells us 10 units. Then you have it to be congruent. So yes, they are similar, because if you do blah and blah and blah and blah, they will end up being congruent. It's kind of a lot, which you don't need in a lot of professions. But in some, it's very important. All right, over here, are these similar? Well, let's see. There's a 5 and a 10, so automatically we know that 10 is over the 5. And that reduces down to 2 over 1. D and F, there's 3 here for D and F. 3. And G and H is 1, 2, 3, 4, 5, 6. So, yup, that reduces down to the 2 over 1. 2 over 1, which is, oops, just 2. And then there's 4 and there's 8. So, yep, that does it too. So you can say, yep, these are similar because the ratios, the fractions, are equivalent. And a dilation is with a scale factor of 2 is one of the transformations that could map it, blah, 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 blah. Okay. Now, if it's not, you're going to see that they don't match. So this is 10 and 5. This is 3, and this is 1, 2, 3, 4, 5, 6. So that matches, and this is 1, 2, 3, 4, and this is 1, 2, 3, 4, 5, 6, 7, 8. Yeah, those would all go with a scale factor of 2. Over here, there's 3, and then 1, 2, 3, 4, 5, 6. So 6, okay. Then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it looks to be that they're similar. You would just then have to check about this and this. If we have this and we double it, because we're doubling scale factor of 2. If we double it, do we get that? Yeah, then it is congruent. If one of these don't match with an equivalent fraction, it's not congruent. So over here, this is 1, 2, 3, 4, and this is 1, 2, 3. So we're talking 3/4 here. This side is 1, 2, 3, 4, 5, and this is 1, 2, 3, 4, 5, 6, 7. So 5 over 7, those don't exactly match. So these are not equivalent fractions, so they are not similar. Not similar. You might look at it and be like, wait, they totally are similar. They're not similar. You can figure it out with the fractions, the equivalent fractions, or the ratios. All right? And that's all I want you to know. I don't even necessarily want you to practice this. Just know that it's out there and that the symbol is the little tilde. Okay.